Hello, everyone, and I'd like to welcome you to this webinar brought to you by the Middle East branch of the Energy Institute, and on the fascinating topic of the psychology of risk perception. The agenda for today is that I'm going to be handing over in a short while to Jack Wishart, who's the Vice President of Risk Engineering for Marsh. Jack's going to be actually sharing his thoughts on the webinar topic, the psychology of risk perception. We're then, after Jack has completed his presentation, we're going to have a panel discussion comprising process safety experts. We're going to be joined by Dr. Umar Abazi, who's the manager of the Insurance Risk Management Department of ADNOC, and Dr. Stephen Bater, who's the author of the Energy Institute's Process Safety Management Framework, which has been revised and is currently going through its publication by the EI. I'm very happy to be chairing this webinar. My name is Lee Alford, and since 2017, I've been supporting the Energy Institute's Process Safety and Decommissioning Program. This event is one of several which will be in the lead up to the virtual conference on Health, Safety and Environment and Sustainability Week, which is scheduled for the 21st to the 23rd of November this year. So just look out for events in the lead up to this in a very similar sort of vein to this one. And of course, we'd like to thank all those who have made this possible, our host partners and supporters. So as far as audience participation is concerned, and before I hand over to Jack, I'd just like to invite you to write any questions in the chat box, which is towards the right-hand side of your screen. You can, if you've got any comments, any observations, any questions, we'd invite you to and encourage you to put those in there, and that can be during the presentation itself or during the panel discussion. And then we'll come to those shortly after the panel discussion. We'll open up the entire session to the audience, and we'll start filtering through those questions and trying to respond to them in the best way that we can. So we're going to allow, we're probably going to try and wrap up the session at 1/4 for those of you who are trying to manage your diaries. So it gives me great pleasure now to hand over to Jack, and Jack's going to take control of his screen.
That's great. Thank you very much, Lee, and good afternoon to everybody. Just going to open up the presentation. Okay, can you see my screen okay, Lee?
I can see it fine, Jack.
Perfect, thank you. So good afternoon, everybody. So welcome to this discussion, this panel forum to do with the psychology of risk perception. Specifically, we're looking at how we can improve probability estimates in risk assessments. Now, a number of us in the Energy Institute, in the energy industry, we're involved with formal risk assessments. But even if that's not part of your job, everybody's doing risk assessments every day, whether that's judging whether it's safe to change lanes while driving, or whether it's safe to eat some food that's maybe slightly past its use-by date. In terms of who I am, so my name's Jack. I'm a chartered chemical engineer by background. Should just stress that I'm not a psychologist, despite the title of the presentation. So I work for Marsh in Dubai as a risk engineer. supporting energy clients, also lead contributor of Marsh's 100 Largest Losses publication, which I can highly recommend. And prior to joining Marsh in 2019, I used to work for ExxonMobil, Fawley Oil Refinery and petrochemical plant back in the UK. Contact details or my email address is on the screen. So if anyone's got any questions or wants to follow up on anything afterwards, do please feel free to drop me a note. So we're just going to start off with a bit of context. I'm going to move on to a discussion about risk perception and what influences that. I'm going to have a look at a case study. I'm going to talk a bit about the 7 deadly sins of risk perception. This is an abridged presentation, so we'll only be focusing on 2 of those. Then talk about the potential negatives of near misses, a bit of a reflection, and then we'll move on to the panel discussion. So in terms of context, so this is a graphic representation of the Energy Institute's process safety management framework. It's represented as a barrier model, got a number of barriers to stop a hazard developing into an incident. And it's split into 4 focus areas: leadership, risk identification and assessment, risk management, and then review and improvement. And this presentation really ties in with the second one of those focus areas. Very important, if we don't identify and assess risk correctly, it's very hard to manage that risk correctly as well. Now, when we talk about risk assessments, we'll often use something maybe like a risk matrix to help structure that thought, that decision-making process. I've just shared an example one on the screen. This is actually Marsh's risk matrix. And it's pretty standard format. We've got consequence on the one side and then likelihood or probability on the other. Now, this presentation, we're again thinking about how we can get the likelihood or the probability part of our risk assessments correct. It's often the harder of the two to get right. And we'll see in the example of the case study we'll look at a time where maybe that wasn't quite correctly assessed with disastrous consequences. So we'll just start by thinking about what is it that influences risk perception. Now, when we consider people's behavior, and when I talk about behavior, I'm talking, this could be on a personal level, this could be on a team level, a company level. What is it that influences behavior? Now, there's 3 parts to this triangle, 3 things that influence behavior. So at the top, we've got the perceived risk. Now, I've put perceived risk, not the risk itself, because although hopefully the 2 are the same, the actual risk, the risk in reality, and people's perception, the 2 may not always be the same. So perceived risk influences behavior. The bottom left, an individual's risk tolerance, that may influence their behavior when making a decision. And the bottom right, perceived ability to prevent occurrence. So what we see is that our behavior may be different depending on whether we feel we have control over a situation or whether we feel we have less control. Now, when we're talking about judgment calls, risk assessments in the energy industry, we're often doing so with uncertainty, ambiguity, and incomplete, possibly contradictory information. We often maybe got some time pressure as well. Now, this makes it a lot harder to make the correct decision versus if you remove each of those factors. Now, when we're talking about complex or risky situations, which we often are in the energy industry, we find that as humans, our ability to perceive and analyze these complex situations is often very poor and can often be disproportionate to the risk of the hazard developing into an incident. In the face of extremely unlikely events or very unlikely events, people often tend to go either one of two ways. Maybe they'll overestimate the probability of an event's occurrence, for example, terrorism, and obviously the probability will vary depending on where you are in the world, or discount it completely. You know, we've got an unlikely event of a meteorite striking the Earth. Often this can go the other way, discount it completely, not even going to think about it, give it time of day because I consider it to be so unlikely. Now, if we focus on this top part, the perceived risk and how that links to behavior, there's a couple of different parts which influence what we see as perceived risk. We've got the familiarity of the risk, the degree to which it can be predicted and controlled, and also the magnitude of the consequences. So we're going to look at two examples here, both of which can have fatal consequences, but both of which the perceived risk often differs. So the first example is terrorism. Now, often perceived to be a great risk. Now, part of the reason for that is it's unusual. Most of us haven't experienced it firsthand. The degree to which it can be predicted and controlled is quite low. The magnitude of the consequences can be catastrophic. If we contrast that with another risk, for example, heat. Now, heat can be seen or can be considered to be relatively harmless, yet it does kill many people globally every year. So why is it that the risk posed by heat is maybe a bit underestimated? Well, as a hazard, pretty familiar. All of us have been hot at one point or another. It's well understood, can often be predicted to a degree with either weather forecasts or if not the weather forecast, the time of year or the time of day when it's going to be greatest. In terms of controllability, we often have some control over whether we're exposed to it or not. We move into the shade or have a cold drink. And therefore, these factors can combine to decrease our perception of the risk. So that's just a little bit to do with risk perception. What we're going to talk about now is an example of a time where maybe risk perception didn't quite go as it should have done. And that's the Space Shuttle Challenger disaster back in January 1986. Now, for those of you who weren't alive then or don't know much about it, just put a graphic here on the screen, and there's three key parts to this. The first part is that sort of white triangular shaped spacecraft. That's the orbiter. The large orange cylinder, that's the fuel tank. And then on the side of the fuel tank, we've got these two solid rocket boosters. And this is what makes up the takeoff craft for the incident. Now, in terms of what actually happened, shortly after liftoff, less than a second later, there was a puff of black smoke, and that was some of the rubber O-rings in the solid rocket boosters failing. Now, what that meant was that some of the hot exhaust gases, rather than coming out of the end of the solid rocket boosters, started coming out of the side. And it started impinging on the strut that was holding the solid rocket booster to the fuel tank. Now, after just over a minute, this solid rocket booster broke away from the fuel tank, and you can see on the right the picture of the devastating consequences that had. Tragically, all of the crew involved in the mission lost their lives. On the next slide, we've got a couple of frame-by-frame pictures showing that flame impingement resulting in the incident. Now, before I move on, there's just one key thing to bear in mind with these solid rocket boosters. So they were manufactured in one part of the USA and made in Utah, then transported to Florida where they were assembled for the launch. And each of the solid rocket boosters had 4 different segments, which were then bolted together with these rubber O-rings, which were used to give the seals. So they're modular construction, and it's these rubber O-rings which ultimately failed and resulted in the incident. So let's have a look at the incident itself. So there was actually a bit of a backdrop to this. So the incident happened in January 1986. There'd actually been a couple of delays prior to this launch. So a number of weeks earlier, the launch was supposed to take place for the first time, and the then Vice President of the USA, George Bush Sr., he was a big supporter of NASA, and he'd been invited to come down and watch the launch. But a few days before, the weather forecast wasn't very good, so NASA contacted him and said, don't bother coming down. It's probably going to be cancelled. It'd be a wasted trip. Now, it actually happened that the weather on the original planned date was fine. The launch could have gone ahead, but by that point it had been cancelled, and nobody wanted to, I guess, contact the Vice President and say that, you know what, we're going to go ahead without you. So there'd been a first delay. A few weeks later, there was supposed to be the second launch, but this time there was a mechanical problem with the hatch on the orbiter. So they had to, by the time they fixed it, the window of opportunity for launch had passed. They had to delay it again. So we get to this incident, and there's already been a couple of delays. We now join the management team the night before the launch, and they're having a discussion with Morton Thiokol, who are the manufacturers of these solid rocket boosters. And the reason they were having this meeting the night before the liftoff is because Morton Thiokol were quite concerned that it was very cold, very low ambient conditions in Florida, and they were worried that maybe those rubber O-rings weren't going to seal properly, may cause an incident. So Morton Thiokol are advising or warning that the launch should be cancelled for a third time, postponed again because of the cold temperatures. Now, NASA are obviously under a lot of pressure. There's already been several delays, and NASA's Deputy Director of Science and Engineering said that he was appalled by this proposal. He said, "When do you want me to launch? Next April?" So this put Morton Thiokol in a tricky position. So the Vice President of Engineering feels torn. So he's hesitant to override the advice of his lead engineer and the others in the engineering department. But on the other hand, he's getting a lot of pressure from NASA, and they've worked together a number of times before, and they want to continue to work together in the future. So maybe they've got some considerations around whether their contract's going to be renewed. So the Vice President of Operations has a word with the Vice President of Engineering, and he gives him some advice. He tells him to put on his management hat rather than his engineering hat. Turns out not to be the best advice. And the challenge that they were basically faced with is, were they absolutely certain that this cold temperature posed high enough risk to justify postponing the launch? And some of the data that they looked at is on the next screen. So these solid rocket boosters, whenever you have a launch, they fall back to Earth and then they get recovered. And it had been noted in previous uses of the solid rocket boosters that these rubber O-rings had failed. Some of them had failed. There have been no ultimately disastrous consequences, but some O-rings had failed. And they were looking at the data, and they were looking at the data of the number of O-rings that had failed compared to the temperature of the ambient temperature for previous launches. And they were looking at this data, and they were trying to weigh up whether the fact that it was very cold, the fact that we were down at around 32 degrees Fahrenheit, meant that there was going to be a problem. Now, if you ignore the blue line, I guess you could potentially argue this both ways. You could look at the the data point at 53 degrees where 3 O-rings failed. You could discount that as an anomaly. And then you can argue the trend goes the other way. Actually, it's hotter temperatures that you need to worry about, not colder temperatures. So this ties back to what we said on the earlier slide, making decisions based on incomplete or imperfect information, or we're trying to extrapolate known data into somewhere where we've not been before. Now, this was the actual temperature when the launch took place. We're way colder than we've ever been before, and actually a large number of O-rings failed. This is what ultimately caused the incident. So it's been a big incident. Obviously, there's an investigation into what went wrong. Now, there was a theoretical physicist, Richard Feynman, who was involved, and his strength is he's very good at looking at a complex situation and distilling it down into some simple themes, simple points. And his findings, his insights were absolutely key in the final report. When they looked back on what people thought the probability of this total loss was, there was an enormous difference of opinion between some of the engineers who had a probability in mind of maybe 1 in 100, to the management who are ultimately accepting the risk and making the decision, believed it to be around 1 in 100,000. And that's obviously a huge difference. If you're about to get on board an aeroplane and somebody said that there's a 1 in 100 chance it was going to fall out the sky, you might think twice about getting on. 1 in 100,000, okay, well, you're getting down into the realms of a very small probability. So there was a clear gap here. Maybe there's a piece here around communication, but there's certainly a piece here around the management levels at NASA had a shortage of pessimists. There's also another piece here where the readiness reviews, they gradually got less strict over time. So previous launches had taken place, O-rings had failed. Ultimately, the missions had been a success. So that became an argument for accepting these flaws going forwards. Now, this is obviously something we need to bear in mind, be aware of. Just because something hasn't gone wrong before, just because that barrier to failure was luck, doesn't mean we're necessarily going to be lucky again. So the Space Shuttle Challenger disaster, there were a number of things that went wrong. This presentation just focused on the part to do with risk perception and probability estimation as well. So this just shows how devastating the consequences can be when we get our risk assessments, our risk analysis wrong. Move on now to talk about some of the deadly sins of risk perception. As I said, in the interests of time, we're just going to focus on 2 of these. The first one is to do with power. It's to do with the effects of power and the effects that can have on people who are in positions of power and their risk-making decisions. So consider an example of rolling a dice. Psychologists ran an experiment where if you can correctly predict the outcome of the dice roll, you get $100, otherwise you don't get anything. And the question that was asked is, would you rather roll the dice yourself? Would you rather have someone else roll it for you? Now, from a probability point of view, shouldn't make a difference whether you're rolling it or someone else is rolling it. But what the psychologist researchers found was that people in power were far more inclined to roll the dice themselves. So I think 100% of the participants who were in positions of power in their respective fields of work, 100% of them chose to roll the dice. compared to participants who maybe weren't in the positions of power, in which 69% said they would rather roll it, and the others said that they didn't mind if someone else did it. So this discrepancy was concluded to arise from the fact that power can increase people's perception of control even beyond one's reach. So maybe we go back to our example of the Space Shuttle Challenger disaster. Maybe some of the people in power, some of the management felt they had a little bit more control over the situation than they actually did. Now, the second deadly sin we're going to talk about is the effects of conformity of thought. Now, this was an experiment carried out by a pioneer in social psychology. And in the experiment, they got people in and they asked them to consider which line is the same as the comparator. Is it A, B, or C? Now, no prizes for getting the correct answer, but what the researcher found is that the individuals, the people who are being experimented on, were put in a group. And in that group, they were actually the only person in the experiment. Everybody else was an actor. And all of the actors agreed that it was one of the incorrect answers. They all agreed that it was either A or B. Now, what the researchers found was that given the pressure of the group, the vast majority of the participants went with the group. They went against their better judgment, and they agreed with one of the incorrect answers. So this is something else to bear in mind when we talk about risk perception. Are our decisions, is our risk perception being influenced by other people? And if so, is it influencing it in the correct direction or the incorrect direction? What we're going to talk about now is the some potential negative sides of near misses and the impact that can have on risk perception. So near misses can actually lower our perception of a risk. Now wait a minute. I think we normally talk about near misses and reporting of near misses as a positive. And absolutely, it's important that near misses are recognised, reported, investigated, and lessons learned from it. But when an individual experiences a near miss, there's one of two ways that they can view it. They can either view it as a success, so, well, actually, no incident occurred, so that's a good thing, or they can view it the other way. Gosh, I was extremely lucky that nothing happened there. I can't let the same situation develop again because I might not be so lucky next time. So there's two ways that an individual can react to a near miss that they experience. Now, again, some research has found that particularly people in management positions who have experienced a near miss, they're more likely, not guaranteed, but more likely to have a lower perception of the hazard probability in future. So what that can then lead to is riskier decision-making in comparison to managers who haven't experienced that near miss. Over time, essentially individuals and also organizations, they can become accustomed to their apparently safe states. They can, maybe some complacency can creep in rather than that chronic unease which is important. And that can result in people misperceiving the risk. Now, when I was putting this presentation together, I was trying to think of any examples of maybe some examples of near misses where they've led to potentially riskier behavior being taken in the future with negative consequences. Now, on the screen is a picture of a front page of a newspaper from 21st of March 2020. The UK is in lockdown for the first time because of COVID-19. Now, this is a newspaper headline. from exactly 2 months earlier, 21st of January 2020. Now, I don't want to focus on the relative credibility of these two in particular journalistic institutions, but the key point is that COVID was known about several months before lockdown was taking place. I do wonder in 100 years' time, when historians look back, when they try to dissect how different countries, how different individuals responded to COVID-19, do wonder if they're going to question why there was a gap in action being taken, a bit of a delay in action being taken. And I wonder if one of the answers that they may talk about or they may conclude was around swine flu. So these are newspaper headlines from 2009. The swine flu pandemic is around. There's a lot of concern about the effects that was going to have and the number of people who are going to die from the swine flu pandemic. Now, people did die from swine flu, but I think I'm correct in saying that far fewer people died from swine flu than have died from COVID-19. So I wonder if this is an example, maybe a time where we experienced a near miss. We warned about how bad an event was going to be. It maybe didn't pan out to be as bad as we were expecting. And therefore, when we have a similar event come along, exhibit slightly riskier behavior. I wonder how many people, how many countries' attitudes back in January last year when COVID was first coming around, I wonder how many comments there were around, it's going to be like swine flu again. So maybe this is an example of a time where a near miss has resulted in riskier behavior being taken than otherwise would have been. So a few final thoughts or a few takeaway reflections from this presentation. So again, what we want to try and think about is when we're making risk-based decisions, when we're trying to assess the likelihood, are we getting that right? Now, a few takeaway thoughts to reflect on. Anybody, can you think of any examples of times where people with power have maybe overestimated their control over a risk? So that was the first of the two deadly sins that we talked about. Would you individually make the same decisions in the presence of other people? Is there maybe an element of peer pressure, of maybe collective blindness when you're making a risk-based decision? When we reflect on near-miss events, and this can either be in your own life or in industry where you're working, are we encouraging that counterfactual thinking of, rather than nothing bad happened, are we instead viewing it as something bad could have happened, we got lucky, we might not get lucky next time? Finally, again, very similar to the counterfactual thinking, we're differentiating between what we call resilient near misses and vulnerable near misses. So, in terms of final thoughts, so Richard Feynman, the theoretical physicist I talked about, came out with a very famous quote. He said, the first principle is that you must not fool yourself. Remember, you are always the easiest person to fool. So always bear that in mind when you're making a risk-based decision, especially when it's about a complex or a more involved situation. So that was everything I was going to cover in this short presentation. I think at this point we're going to move over now to a panel discussion.
That's that was an excellent presentation, Jack. Very thought-provoking, very topical. I'd like to ask all members of the expert panel now to unmute themselves and put their their video on, so that they're all visual, if we can do that. And we've actually prepared some questions that I'd like each of the members of the panel to try and respond to, having been stimulated by the thoughts presented by Jack during his presentation. So a key use of a risk matrix is in risk assessments, where one will typically be moving from an unmitigated risk to a mitigated risk. This ultimately determines beg your pardon. Okay. So yes, this ultimately determines whether the residual risk will be accepted or not. What are the key challenges to correctly placing a mitigated risk on the matrix? I'd like to invite Dr. Umar Abazi to have a go at actually responding to that, if that's okay.
Absolutely, Lee. Thank you very much. And first of all, Jack, a wonderful presentation, very informative and well done. First of all, let me just highlight the fact that I'm sitting in an open office. So if you see people wandering around in the back and trying to speak to me, or you hear phones ringing, I do apologize in advance. So I just wanted to let everybody know of that. So thank you, Lee, for that question. Just building up on the presentation, I was just taking some notes while Jack was presenting, and some of the key terminologies that I picked on was decision-making, overestimating, discounting of risks, and visibility. And I think these are the key things that come out and need to be highlighted as part of answering this question. Because the fundamental purpose of a risk matrix is basically bringing the visualization of the risks for any company, risks that the company or the corporate sees as something that would actually, derail them from their strategy, and more importantly, that exposes them to any, unwanted events. And when we talk about moving from the mitigated to an unmitigated part, I think what is more important about, the placement of a risk is what is the ground level reality. And I think it all depends on the reporting and the understanding and the visibility of the truth of, the barriers and the controls we have in place when we talk about the risks which are being placed on the matrix. So if we are to sort of move a risk or change the ranking of a risk, what is more important is to have that visibility and understanding of the efficiency of our controls. And there are various ways of doing that. There are KPIs, there are certain other reporting mechanisms. There's this auditing that you have, for example, your assurance mechanism. So all of these things, how effective they are, what's the visibility of that, and what kind of a culture you have of reporting in a company. I think all of these determine the efficiency of your placement of the risk, and then subsequently obviously allows you to determine whether a risk can be ranked differently how it originally was on a risk matrix. Does that answer, or do you want me to go into more details?
No, that's absolutely a very thorough and full response there, Umar. Thank you for that. Very considered. Stephen, would you like to pick up on maybe what Umar has just said, or add any other further comments?
No, thanks very much for that, Umar, and thanks, Jack, for a lovely presentation. Again, from my perspective, the issue with risk assessment is basically making sure you have a systematic approach, the complexity of oversimplifying, not taking things that are relatively static or dynamic over time. And basically, from my experience, where it works is having a system that's aligned to a robust management process that includes the right people who are trained, have got the relevant knowledge, expertise, and experience, and they assign the risk ranking and mitigation correctly. And from a practitioner's perspective, I found it quite useful to have more than one person or more than a team approach. So you avoid the potential for being either risk adverse or risk cavalier, like Jack expertly presented, where you get different drivers in that, and it tends to moderate and you get a far more robust process. So that's from my perspective, lads. Yeah. And again, if you look at the framework, it's one of the focus areas as Jack presented. It's risk managed identification assessment, and also element 6 and element 17 provides excellent guidance for people who want to implement a robust process for managing this aspect of their risk management tools. And also, just again, to pick up on Umel, process assurance, auditing, it's an essential part of the checks and balances that we need to be doing, lads.
Thank
Okay,
you.
Lee?
Yeah, thanks for that response, Stephen. Just before maybe we return to Jack for perhaps some further thoughts from him. You did mention that that risk is maybe better assessed as part of a group, but we do have the prospect perhaps of groupthink creeping in. I mean, can you offer any antidotes to conformity of thought or groupthink?
Is that for me, Lee, or?
I was going to, of course, please take that.
No. I just thought
that's...
like, because everybody went quiet, so I was just trying to understand. So it's back to you, Stephen. So please, over to you.
Yeah.
Okay, sorry, guys. Yeah, from my perspective, lads, if you get the right people around the table, you can avoid groupthink, Lee, by sitting there, discussing the opportunities, and it actually benefits by calibrating the team. And then once people present either the more sort of pessimistic approach, the other guys, and I've just found you overcome it collaboratively working together, because, you know, at the end of the day, you're doing the process, you're following it, using the same systems and tools and working to get to an end point. And I actually, in my personal experience, if you get the right trained people with the right knowledge, expertise and experience, and you're following a systematic approach, it tends not to be problematic, Lee. I hope that's okay.
Yeah, no, that's great. Jack, can you offer any further thoughts based on what you've just heard from Umar and Stephen?
Yeah, no, I absolutely agree with what's been said before. For the specific question about groupthink, I think it's absolutely key that if you have a group, the person who's chairing that discussion, you know, it empowers everybody to say their part and doesn't maybe let the conversation be dominated by one or two views. So it's really important to have that, I guess, environment where people are freely able to raise their concerns without fear of being shouted down or anything. So that's kind of my other thought on the barrier against groupthink, but absolutely important to get the right people with the right training and experience in the room. For this specific question, the only other thing that I would add, or the only thing that I would reiterate, is the difference between the unmitigated risk and the mitigated risk is the barriers. Now, those barriers are more often than not going to be reducing the probability rather than affecting the consequence. Not always, but often the case. In order to facilitate getting that judgment right about what is the mitigated risk, the more specific and the clearer the barriers can be, the easier that is then to place the mitigated risk. If we've got a very specific, or a smart, specific, measurable, attainable, realistic, time-bound mitigation, then it's an awful lot easier to assess the mitigated risk compared to just a high-level couple of words about what the barrier is that we're talking about. So that's the only other thing I would add.
Okay. It might be worthwhile actually taking some of the questions that have been asked actually in the chat box, if that's okay. I think this question's attracted quite a lot of interest. There's quite a good question here from Simon Rosser. Is consensus always desirable? when group thinking mixes with power. Surely this was one of the factors in the Challenger explosion. Does anybody want to come in on that one?
I'll come in on that, be a bit contentious possibly, Lee. No, consensus is not always the outcome. It's not always the desired outcome. As long as there's been an agreed process where sometimes you've got to agree to disagree, and the sort of experts in there make the final decision, and they're held accountable for their decision. It's only when you get sort of an overzealous approach to power where everyone's, I'll use the term, yes man, and in agreement. And that's where I believe the balance of the team, the correct selection of the team, like Jack said, having a group leader is in high hazard. That's my experience when you don't have the issues around the Challenger, because you get the robust challenge and balance that decided before you come to a final agreement. And sometimes there will be a agreement to disagree, but that's the process that'll take the business forward with respect to the risk management.
Okay. Very good. Umar, would you like to maybe add anything to what Stephen's just described there?
No, I fully agree with Stephen. I think the fact that, capability is critical to this process, and it's the core of sort of like, bringing a group together and ensuring that the right people are around the table to brainstorm on something about, when it comes to risk ranking and risk evaluation. And yes, at the same time, it's not something that where a decision needs to be influenced. The integrity of what's being assessed and evaluated is fundamental, and it needs to be upheld, because at the end of the day, the fundamental fact that why we're doing this it brings us to a position where we need to understand how we can align with the strategy of any company or what we're trying to achieve.
Mm-hmm. Okay.
So fully agree with that. Yeah.
Great. Let's shall we move on to our next question? So this is a perennial issue, I think. What is the sensible range of probabilities and likelihoods for a risk matrix? Umar, would you like to try and have a go at that one?
Yeah, so when it comes to risk matrices, there is some level of variation when you go and work with different companies. It's quite reliant on the appetite of the company. I mean, I've worked with companies where the risk ranking starts with a probability of more than one event a year, to somewhere where they would consider starting from 1 in 10. So the probability ranges vary, and it's more to do with the exposure of the company to events. There are companies out there, obviously, who've had like more than 2 major events in the history of their operations. Then there are those who actually are not that exposed. So their perception of, or their approach to manage risk would be slightly different. And I've seen some of the questions actually being posed here are in the same context of like, what those approaches would be. And, and if we're talking about the psyche or the psychology of how risk is perceived, I think that has a lot to do with the company and how many incidents are there past when it comes to like, major incidents and their understanding of major risks. So I think when we talk about a sensible range, I think it's more to do with the appetite of the risk appetite of the company, how much of a company's been exposed to incident, and how much they are willing to take the risk of any future events. For example, I mean, we've known companies operating in the North Sea back in the 80s, and not too long ago, where actually they've been barred from doing business anymore, and just for the sake of having incidents. So companies like that probably would have a different perception when it comes to having the range of probabilities. They might not be able to afford a single more incident. So in that respect, there's a range, but the most sort of like predominant range would be something in the range of 1 in 10, going up to like 1 in 10,000, or something on those lines. But there is variation, but there's not a huge variation, something on those lines. But then again, it all comes down to the threshold that the company is willing to take.
Thank you, Umar. Maybe I'd like to go back to Jack on that one, and maybe Jack, have you got anything further to say based on Umar's response there?
Yeah, no, I agree with Umar. The only other things I'd add are risk matrices are often proprietary. So if you do Google for companies, you may struggle to find it. There is a range across the industry. I'd say the example that I had on the first screen, which I think ranges from 1 in 10 years to 1 in 10,000. That's a pretty common range, or not a million miles away from what a lot of companies would have. Now, the only thing I would say is that having a sufficiently wide range is absolutely crucial. I have seen some sites which have had quite condensed ranges. So I think the most condensed I saw was a range from once per year down to the lowest group, which was at least or less than once in 25 years. Now, obviously, that's not really wide enough for process safety risks. If you took the example in that specific risk matrix of looking at a catastrophic event with multiple fatalities that had a once in 30-year frequency, that was actually coming out as a category 3 risk, which is starting to border onto acceptable, which is clearly doesn't pass the funny look check. So there are ranges out there. It's important to have a wide enough range to cover process safety events, which when you're looking at an individual site, the probabilities and likelihoods of a major fire, a major explosion, thankfully can be quite small when you're just looking at one site in isolation. So that's the only other thing I would add.
Thank you, Jack. Do you have anything to add to that, Stephen?
No, just agree with Jack and Umar there. From my perspective, this relates to the risk profile and appetite of the organisation and their risk management and the matrix used. From my perspective, it's prudent to consider a range of probabilities in order to include a range of uncertainties, because especially when we try to use historical data, as the past can never be assumed to equal a future, and we've seen areas of industries relying on historical data to inform the decision making. If you look at the nuclear industry, for example, process safety industry, what Jack is alluding to. So at best, it is used as a point of estimate. Uncertainty will always exist, and you need to consider the limit of our capability as humans to estimate events. But it's again, Lee, from my perspective, it's all down to the robust approach. Like Jack said, some of these are sort of industry specific. There are some very robust tools developed by the regulators, but it's all down to the knowledge, experience, and expertise and training of the team in applying these metrics. Do you know what I mean? So again, based on a framework, follow the appropriate process and train the lads appropriately. And I'm sure you'll come up with a good decision at the end of the day.
I've just been looking at the chat box for questions, and maybe I'd like to put this to the panel that seems quite relevant to this question. What do you think of including what's called risk velocity in the risk matrix? Have you come across that concept at all, Jack?
I don't think so. I'm not sure what's meant by sort of risk velocity.
Is that down to the dynamism or the ever-changing nature of the risk? Umar, have you come across risk velocity as a concept?
Not really, no. I'm not really that familiar with this term, to be honest.
Okay, let's
qualify just my experience of it. Actually, I've come across it. It's the dynamic nature of the risk, how things change in a fluid nature.
Right, okay.
Yeah, there we are. Risk velocity is the speed with which risk may materialize.
Okay, okay.
So again, yeah, if the complexity of the operations, from my perspective, Lee, the complexity of the processes and risk matrix used, that'd be a good opportunity for people to do a site-specific risk assessment using their risk matrix and their controls to inform their decision-making and risk ranking. Yeah. Okay.
So this is really moving the risk assessment down to the operational level and the day-to-day.
Distilling down more to a bespoke site-wide, as Jack said, or industry specific for a known risk. Yeah, it's a dynamic process as things evolve, as the situations change. These systems are going to change and develop over time.
Yeah. So Lee, if I may, looking at the chat in terms of what's being said now, so a low risk may become high if the velocity is high. I think the dynamic nature of the risk, that's one thing, but I think what is more important is, which is a key factor, which we take quite seriously here in ADNOC, is about continual improvement. When it comes to risk management, I think there's one thing that needs to be understood, or I think is a concept that, you know, I've seen across in my experiences, that, you know, there's nothing like there's ever going to be no risk at all, especially in a hazardous, the nature of our business here in the oil and gas. So in that perspective, there's always needs to be some level of continual improvement. So if your low risks are moving to a higher level rather than the other way around, which is the objective of you know, risk management, then I think what needs to be considered is, like, you know, as Jack mentioned earlier, is about your barriers, the efficiency of your barriers. And I think that also has to be sort of like, you know, alluded to the fact that, you know, whether your auditing processes, your assurances processes are giving you the true reflection of what's happening on the sites on the ground level. So just highlighting something, you know, considering the risk velocity and the dynamic nature of thing. I think if you have a good continual improvement mechanism, which is part of your PSM sort of like, you know, framework, then I think it should be going the other way around rather than going from a low to a high level. Oh, back to you.
Yeah, thank you, Umar.
Just to add one point to Umar's point there, Lee, from my perspective, all of these tools and techniques and risk management and risk perception need to be embedded in a process safety management framework, and it needs to be valid. The assurances need to be carried out where you're having audits, they're reviewed, the correct people, etc., etc. And then you're managing your risk profile by using a system. That's my view.
No, it's a very good point. Excellent. Jack, do we have another question for the panel?
We do indeed. And sorry, the only other thing I would just add on risk velocity, I guess what that's coming down to is how quickly your risk assessment may become out of date. So if you assess a risk on a certain day and it's got a very large velocity and it's changing quickly, then that's a key point that you're going to need to repeat that risk assessment exercise maybe a bit quicker than a low velocity risk. In terms of a three-dimensional risk matrix, I think I saw in the chat, I've not come across that before. The thing I do like about a two-dimensional one is sort of the keep it simple philosophy, in terms of it's something simple, something straightforward, which you know, people at all levels of the organization can understand and use without too much training or experience.
Thanks, Jack. Yeah, that was a very good point you've just made about keeping risk assessments up to date, especially in a fast-moving environment. How about this next question? How and this is where really the rubber hits the road. How can I practically improve the likelihood estimates made during risk assessments at my site? And I guess a lot of people on this call will be asking that question. Can I put this one to you, Stephen, based on your experience?
It's a frank question, Lee, and I'll give you a very frank and straightforward answer. This is basically down to asking the right questions, using the correct processes with the correct team to carry out the risk assessments on your sites. It's making sure you've got the right team following the right process to fix your risk profile, and you do it in a collaborative approach to identify the goal where you're trying to achieve. Do you know what I mean? It isn't overly complex, but you've got to have the right people there with the checks and balances of risk averse against, you know, the management power decision making. And as I say, in my experience, you get the right people. Like Jack's a chemical engineer, I'm an environmental engineer. You get electrical engineers. You get the right people there with process people. You get the right outcome. You've got to have the right people involved, guys. It's got to be given due diligence, following a robust framework, a process that's bespoke to your risk profile, and it does what it says on the tin from my perspective, Lee.
Can I come back to you on that, Stephen? Yeah. What do you think of having, as Jack mentioned in his presentation, some pessimists within the team?
Again,
or devil's advocates.
Yeah, absolutely. Again, you've got to have the challenge, lads, because sometimes you're looking for the easier option. Some people will tend to go gold-plated, if you like, and they want to do it. All these things tend to cost money. There's got to be a degree of pragmatism in there. Not everyone has got that level of exposure or experience. So having a devil's advocate there, having a critical friend, if you want to call it that, having someone to retune the dial a little bit to make it a bit realistic, loss prevention engineers or insurance professionals, I think they all add value to this process.
Umar, would you like to come in on that one?
Yeah, thanks, Lee, and I agree with Stephen. I mean, most of the things have pretty much said by Stephen, but there's a certain element of qualitative and quantitative aspect when it comes to likelihoods. I mean, if you look at the structured, very rigorous QRA approach, you have your parts counts, you have all of these things which is based on historical data and all sorts of other data available in the market or in the industry that gives you or allows you to pick the right likelihood if you go to the granular level. But then at the corporate level, such as like when you're looking at the ERM processes, you have some level of a qualitative approach, a subjective approach, and in that respect, I think I agree with Stephen that there is somebody who has to be the devil's advocate, somebody who has to be a pessimist and come in and challenge every justification there is in the book to say why you're ranking a certain risk at this level of likelihood or whatever it might be, but at the end of the day, I mean, in the context of why we're here of this forum, I think it all boils down to the fact that where is the visibility of the truth of the ground level realities. So there's a certain aspect of like understanding like the learnings of from incidents, the learnings of what's happening outside of your domain of your sort of like the company or your operations, because there's a certain aspect of the risk matrix that is also determined about like whether something's happened in the industry or not, because at the end of the day, in some cases there are some black swan events, and we have seen that. I mean, not every event repeats. Sometimes a major incident in industry could be the first time it's happening to someone. So all of these things, all of these perspectives needs to be there for anybody who's being part of that process. Just to add that a little bit.
Thank you, Umar. Somebody in the chat box has put a very specific question to Jack, and it's why risk perceptions vary in different countries and among experts in different countries. Can Jack, do you have any sort of thoughts on that?
Yeah, I can have a go. So in terms of, I guess, risk perception and learning from losses, there's a couple of barriers to why people don't learn from losses, or things that can impact learning from losses. Now, in terms of different countries, what I would say is some countries are very good at investigating and publishing the learning from losses, sharing them widely. I think the Chemical Safety Board in the US, they do a really good job of process safety incident happens, they publish the YouTube animation explaining what happened and why. That doesn't happen so much in other countries. I think there are some countries where losses are maybe kept a bit quiet. They don't want to lose face for whatever reason. So that can certainly change the risk perception of people based on maybe where they are in terms of how much exposure they hear about different losses in different industries. If you're in a country where you hear a lot about, oh, there was a loss here and a loss there, and there's information sharing, that can impact your risk perception compared to maybe if you work somewhere where losses aren't freely reported or they're not as widely communicated, then that can also change the risk perception piece as well. So then maybe that's one thought I have in terms of our risk perception can depend on what we learn from losses, and how much we learn from losses is partly influenced by individual governments, regulations, regulating bodies, whatever it may be, and how much they mandate that information losses need to be investigated and the learnings shared.
Great, thanks, Jack. Another question that I've just selected from the one of the audience. Coming back to the Space Shuttle Challenger incident, does anybody have can anybody offer how that could have been avoided? So any thoughts as counterfactually, I guess, how that might have how that incident might have been avoided? Jack, I know you presented on the case study during your presentation. Do you have any thoughts on what might have happened differently?
Yeah, so I guess this presentation is really focused on, I guess, the culture, the risk perception, and the risk-based decisions made at the time. Now, I think even to this day, some of the management who made those decisions still argue that they would have made the same decisions, if they went back in time, because they were making the best decisions that they could with the information available at the time. It's very easy to have 2020 hindsight vision with the benefit of the full investigation report that was done with the insights of Richard Feynman and the others, explaining what should have been done to avoid the incident. Obviously, this presentation is really focused around the culture, which maybe could, and communication, which maybe could have been improved a bit. I think there's probably there's a whole host of like with any incident, it's very seldom one specific thing which causes the incident. There's a number of contributing factors and so on. So I think you could probably spend a few hours or maybe do a multi-series podcast into what went wrong with the Space Shuttle Challenger incident and the specific learnings from that.
Okay, let's open this up in an even broader sense. I'm just dipping through some of these questions now. There's a couple of questions on digitalization, and I'm just going to select one of them. How much can we rely on the digital way of doing HAZOPs or using artificial intelligence, machine learning? Would anyone like to come in on that particularly?
Again, I'd like to jump in, Lee. I think there's a tremendous opportunity and there's a lot of great work going on in the AI machine learning space. We've worked with EI to develop some software tools and expertise. Again, it's down to the right people making the right decisions, using the right tools, and not just using it to sort of support their argument, if you like. And I've just picked up in a similar vein, Lee, a question from Emma linked to the Challenger incidents. How do we increase the voice of engineers? Where are engineers in this power group, if you like, in organizations? Is there enough of us there that know the language, know the tools and techniques to actually inform this decision making from an organization or a sector perspective? That's basically a bit of a double-edged sword there. So yes, I think AI is fantastic. Machine learning, you've got to have the right people involved in this decision-making process. And we also need the right caliber of people in the power cadre of organizations to be able to balance this risk perception against reality, against what drives businesses, which is economics. So hopefully that's sort of stirred it up a little bit.
Yeah, Umar, that's quite controversial, I guess, or provocative. This sense of striking a balance between engineers and managers. Does it necessarily have to be adversarial?
I mean, let me just pick on the fact that, we are in the era of digitalization. I mean, going forward, especially here in the Middle East, and, speaking of, if I mention something with regards to where I am at the moment, our company is really pushing forward for the digitalization, and, considering the challenges that we've been facing over the last year or so because of COVID has expedited that significantly. I wouldn't disagree with the fact that these tools are useful and they would at some point would prevail. But if I put my engineer's hat on, I mean, I'd like to go and really kick the tires myself physically by being on the site and seeing things, by touching and, even regardless of being a manager or not. I mean, even when we do our risk engineering surveys, my always my approach is that, you know, if we can go physically see things, it has a different feel to it. But nonetheless, we have to adapt. And you know, coming to the fact that, you know, and I think there is some relevance to the fact, the voice of engineers, because if we are going to really exponentially move into the digitalization era, then the use of engineers and their sort of like expertise is going to somehow be inversely proportional to that. It's going to somehow sort of like, you know, be undermined. Having said that, yes, I mean, there is going to be some experience of engineers, some technical aspects that's going to help building those tools, but we're talking about the future here. So yeah, so we are moving in an era. We just have to adapt. At the same time, we need to see how much of you know, that process we can adapt to, and see how we can make sure and ensure that it's efficient and effective as much as possible.
Great. Thank you very much, Umar. I'd like to give the penultimate comment back to Jack, and then we're going to I'm going to try and wrap up the session. So over to you, Jack.
In terms of the question around AI and machine learning.
Yes, or any other reflections around engineers and the balance with the managers.
No, absolutely. I mean, I agree with what's previously been said regarding the specific question to do with technology. Of course, it's, you know, absolutely exciting. I think it's something that we're going to see more of going forwards. In a HAZOP, we're relying on the skill and the knowledge of the people in the room. If we have software that has experience and knowledge from thousands of sites and previous HAZOPs, rather than just the tens and hundreds that maybe the individuals have, then that's clearly going to add something. That said, there's the old saying with models and software, rubbish in equals rubbish out. It's really important to give the right information to the software. And I think that's a skill still of engineers, maybe sense checking data, spotting errors, whereas I'm not sure at the moment whether any AI or machine learning would do that so well in terms of the sense checking. But that's kind of my thoughts on it. I think it's really exciting though, and be interesting to reflect, you know, in 10, 20 years where we go with that.
Okay, that's lovely, Jack. I'd like to thank you for your excellent presentation today. And I'd also like to offer a vote of thanks to our experts, process safety experts, Dr. Umar Abazi and Dr. Stephen Bater. There's been a few questions about whether this webinar is recorded. I believe it is, and I believe it's going to be shared. And the slides would be available during that particular recording. So I'd like to thank all three of our main contributors. I'd like to thank everybody for their time and attention, and the questions that have been put in the chat box. Those who have joined us for the webinar. Please look out for further webinars on HSE and sustainability leading up to that virtual conference in November. So I'd like to sign off from there. Thank you very much for today. Have a great rest of the day. Thank you.
Thank you very much.
Everyone.
Thank you.
Thanks,
Thank
everyone.
you.
Bye, everyone. Stay safe.
Bye.
Thank you. Bye-bye.